Hey everybody, you made it. This is the last section. This section, just kind of kick back and relax, absorb everything. We're going to talk about some various strategies for making your life as a developer or as a DevOps guy as easy as possible when you're working with the Mongo database. So let's get started. And in this video, I'm going to take it kind of easy on you, and we're just going to talk about best practices for deploying and maintaining the Mongo database. Now, I've been working with Mongo for about 14 years, and I've learned a few things in that time, and hopefully I can pass some of these things on to you and make your life a little bit easier by doing so. So, first thing I want to talk about is, most importantly, put your database in a non-root file system. Now, since most of this product has been geared towards the Linux operating system, we did talk about this way back in the beginning of this video. When you're deploying Mongo database, please don't deploy the data files and the log files, for that matter, into your root file system. You want to keep your actual deployment of the Linux operating system and of your third-party services like Mongo as versatile as possible. And what I've learned over the years is, even if you're on a development environment, have at least 2 hard disk drives, or at least split up your only hard disk drive into 2 partitions. Install your root operating system, your Linux, into your first partition or your first hard drive. Install your services like Mongo database, and then reconfigure the database so that the data files and the log files are written to the second partition or to the second hard drive. And the reason why we do this is, over time, operating systems evolved, and you may have to upgrade to a new operating system, or you may have to switch operating systems and install something new, completely new, wiping out the first partition or the first hard drive. But the data will be protected if the data is located in the second hard drive. So in other words, if you had one hard drive and you just threw everything in the one hard drive, let's say you got a 4 terabyte hard drive on your laptop or on your development box, and you don't bother to partition it, you just throw everything into there, that's fine, it'll work for time. But if the hard drive fails, you've lost everything. And if you don't have a backup, you're really kind of in a bad spot. If you repartition the hard drive into 2 partitions and you put your data files in one partition and your operating system in the other partition, you're still going to have a problem if the hard drive fails. If you have 2 hard drives, putting the database and the log files, especially for journaling on shards, if you put that into the second hard drive and the first hard drive file, the first hard drive fails, of course, you're safe. If you have to reinstall the operating system, you're safe, because all of your database and your database log files are not stored on the root file system or in the root partition. So if you have to go through a reinstallation of the operating system, you won't lose your data. And of course, you'll have to reinstall Mongo and reconfigure it, but that's okay, because if you're a developer or a DevOps guy, protecting the data is the most important thing. Even for a development database, nobody wants to recreate a development database. So try to protect your data by storing it separately from your root file system. Trust me when I tell you, I've actually encountered this personally before, where I've lost or corrupted the root file system so badly. I've changed flavors of Linux. I've done such a huge, massive upgrade that I had to reinstall, or I get a laptop from the vendor and I don't like what version of Linux they've installed, and so I install a version that I like. And in all cases, as long as I've had my databases not stored on the root file system, I've been able to always recover 100% of my data by doing that simple little trick. And even if you're developing on a single node where you don't have a sharded cluster or a replication set, remember to take frequent backups. Mongo dump is very fast. It works from the command line. In another video in this series, we'll get into backup and recovery in more detail. But Mongo dump is a very simple command. I put it on the screen for your enjoyment. And you basically type it in, and it'll back up a fairly large database. And again, if we're talking about a development database, which is obviously smaller than production, it just backs it up in a few seconds. And then restoring it is just as easy. For the restore command, I actually giving you an example restoring to a replication set. Whereas for the dump, I'm giving you an example for a single node instance of Mongo. But in either of those two commands that are on your screen, you can see how simple these commands actually are. Backup, backup, backup. Take frequent backups. One of the things I like to do as a best practice is on Friday, you kind of got Friday-itis when you're working and you're slowing down, you're looking for something to do between 4 and 5 o'clock. Take a snapshot of your database. Nobody ever was hurt by taking too many backups. Okay, moving on. Next thing we want to talk about is development environments, QA and test environments, and production environments. In a typical shop or where you work, there's going to be at least these 3 environments that somebody has taken the time to set up, or maybe they're coming to you and they're saying, hey, you're going to write this application and we need to set up a deployment environment. Deployment environment is so that the code can get out of the developer's laptop, get up to QA for testing, and then once QA signs off on it, it can go to production where the users can get their hands on it. And in each one of these 3 environments, we have different hardware configurations. And of course, production, everything's replicated, everything's duplicated. You have failovers out the wazoo, and very expensive to run, even with a minimal sized web application operating in the cloud. QA is kind of a little bit scaled down version of that, in that you're also testing the architecture of a production deployment, but you may be using smaller machines, lesser amounts of data, and you don't have the degree of replication always turned on that you would in a production environment. And then the development environment is relatively simple. Your development environment, you could have everything operating on one laptop like I do. I also have configuration set up on my laptop where I can connect to a single node instance of Mongo, or I can connect to a replication set that I have set up on my network, or I can connect to a sharded cluster with full replication also set up on my network. And I can do that through the application configuration software. The point being is that the development environment is usually much more simple and could potentially run on a single machine, or you could run it in a virtual environment on a virtual machine or a VM, or you can use containers to install the various services and configurations on your machine or on a variety of machines. So you've got a lot of flexibility and potential in terms of how you set up the various environments. And I'm going through this, especially if you're a new developer or you're new to the business. This is kind of a great background information for you to know about when you go to work and you start to work in a large shop and you hear guys, engineers talking about, well, it's in QA, or we're going to push it on pre-stage or post-stage or whatever. There's other environments that you can have besides the basic 3. Pre-stage environment is, well, I'm done developing on it. I'm pretty sure that it works, and I'm going to push it into this queue so QA knows that it's available for test. They're busy testing something else, but it's in pre-stage waiting for QA to pull it out of pre-stage and push it onto QA. And likewise, once QA gets done testing, they could push it to a post-stage environment where the marketing manager or the product manager can take a look at it, and they can decide before pushing the button on whether or not to deploy it into production. I've also worked in shops where we've set up duplicate environments for the pre-sales team so that the pre-sales team can go out and demo the product to customers, or we could put advanced new features that haven't been publicly available yet on, say, an alpha or a beta environment. Demo environment is the same as pre-sales. It's on your page, on your notes. But the point is, in a shop, you could have many different environments, and if you're the DevOps guy or the developer wearing 2 hats, it's your responsibility to maintain these environments. In a production environment, everything centers around failover and replication. So at a base minimum deployment, let's say we're talking about a web application here that users can send chat messages back and forth to other users. And the application system, the application servers that the users connect to through their browser would be managed by a load balancing server, an LBS, in the cloud somewhere. And the LBS would round robin traffic coming from the clients to the application server 1 or application server 2. In some configurations, some shops I've worked at, the LBS would have all traffic routing to application server 1, but if application server 1 failed or went offline for whatever reason, the LBS would start routing all requests over to application server 2. So the point being is that even for the front-end web app servers, you have redundancy and failover. In a clustered environment, in a production system, you could actually mirror the entire environment that we're talking about in a secondary failover environment that remains dormant. It could be in a different geographical location, and it remains dormant if the first environment or the first supercluster goes offline. So again, production environments, very expensive, very intensive, lots of machines, high performance, etc. Your backend data servers are kind of configured the same way as the front-end application servers. If you have them, they'll be managed by a load balancing server, and you'll have 2 or more backend data servers handling requests from the front-end app servers and managing those requests back to your clustered data service, which in our case, we're talking about MongoDB. And in this diagram, we're showing a 2-node sharded replication set. So our data is perceived as a clustered service as far as the backend data applications are concerned. And we put load balancers in front of the front end and the backend servers so that we have a well-defined IP point. And that way, I only have to connect to the load balancing server, and I can add as many backend data servers or as many front-end web app servers as I want. The load balancer has the responsibility of keep tracking them and who gets the next request. So that's a fairly typical production deployment for a data-intensive app. A QA environment is going to be a scaled-down version of the production environment. Obviously, you're not going to have the supercluster failover. You may have fewer app servers, if any. You may not even have load balancers. And instead of having a sharded database cluster, you may have just a single replication set. But the point of QA is not only to test the software, it's also to test the environment that the software runs in. A lot of shops that I've been in, the QA people have wisely set up an environment that it's as close to production as possible. And because of the huge costs associated with maintaining these types of clusters, sometimes the QA test environments are set up so that they can be spun up or spun down as needed. Another distinction I want to make between QA environment and a production environment is that in a production environment, you would have auto-scaling enabled so that, for example, if you start to get crushed on the front-end web application servers, the scaling service will add new application servers to the load balancer as needed, and as load decreases, they can be taken offline. Whereas you obviously wouldn't have something like that in a QA or test environment. And then finally, in the development environments, I say laptop because most developers these days work off of laptops, but that doesn't mean you can't work off a desktop machine. But the point being is that in today's environments, most developers either have a self-contained environment where all the services are available on one machine that they use to write software on, and their database, their messaging system, whatever, is installed on a single laptop. And this is actually a pretty easy deployment for IT to manage because they can just burn these images to various laptops and then hand them out to the employees as they need it. Or you could have a little bit more complex environment. I actually have both of these environments in my house, for when I do my work. And when I go into the office, my laptop is capable in a self-contained environment. But when I'm working out of the house, I can change my configuration files and I can access different boxes on my network to test my ability to work with replication sets or test my ability to work with sharded clusters. And by that, I mean, for example, when I'm writing code to access a database server, if I'm issuing a command to just fetch data from the database, in other words, I'm issuing a non-destructive database command, then I want my application to pick up that request, recognize it as a non-destructive request, and send that request off to one of the slave servers or one of the replication set nodes to handle that request instead of to the master or the write service, because we're just doing a read and I don't want to block the read request because it's already doing a write, or I don't want to block a write request because it's already doing a read. So point being is that when testing your application, one of the main reasons for testing a replication set or testing a sharded cluster is to make sure that your application is sending the data request to the right nodes within the replication set.